So I'm back again with a flipbook, and hopefully you were able to cache your particles as well. And this is the result. I think it's looking quite good. Remember, we're caching this simulation with a particle separation of 0.1, which is relatively high res. The thing with this scene is it's quite a large extension of water. So let me bring to your attention two things that we need to address. First of all, if you take a look at the initial frames, let me stop the animation around frame 14. So notice how, especially here to the left, we see a huge splash where the particles are in contact with this collider. Now, this is relatively normal. Usually a flip simulation will take a few frames before it completely settles down. And this part doesn't really concern me much because the fix is relatively simple. So there's two options that you can do here. First of all, you can add certain pre-roll, and this means you can simulate a certain amount of frames before your first rendered frame. For example, in this specific simulation, we probably need to simulate 30 or 40 frames before we start rendering. Another solution, and that's the one that I decided to go with for my final render, is to just render a flat plane and then do a crossfade with the simulation once the simulation has been settled. And that would be around frame 40 or 50. So I decided to go with that solution because it's cheaper in terms of the simulation times. You wouldn't have to simulate pre-roll. It's also cheaper in the sense that you don't need to cache those extra frames to disk. Another very important thing that I want you to notice is that my domain is not reaching the edge of the frame. And of course, if we currently mesh this and render it, we would see a gap here. We could extend the domain, but given the angle of the camera, we would at least need another 20 or 30 meters, which would greatly impact in simulation times and caching. So in this case, the solution will be the moment we start meshing the geometry. The final thing that you may be wondering is what happens with all the detail that we had in the render. So currently this is a flat simulation because there's no wind, there's no forces acting on the particles. Currently all the motion will come with a collision, and that won't happen till about frame 190. So the way we will handle all this detail, and you probably already guessed it by now, is with an ocean spectrum. So first things first, let's take a look at the meshing tools. Let's create a geometry for our simulation, also extend this geometry, and then we will take care of the ocean spectrum.